good early afternoon, depending on where you are on the continent. I want to welcome you to SFI's Canadian Forest Carbon Assessment webinar. This is a webinar that is a result of our SFI's conservation impact work. My name is Darren Sleep. I'm the Senior Director of Conservation Strategies with SFI. In addition to hearing my voice on the line today, you will also be hearing from Mark Johnson from the Saskatchewan Research Council and Werner Kurtz and Byron Smiley, both with NRCan CFS, who will be walking you through this presentation. I'll remind you now that this presentation is being recorded, so if you missed it or if you know somebody else in your organization who missed it and would like to see it, you can catch up on it later on, and we will distribute the information as to how to go about doing that. Now, just by way of quick introduction to SFI and SFI's conservation impact work, I want to remind you, excuse me, that SFI we're primarily about sustainability. We are a solutions-oriented sustainability organization that works primarily with forestry, but also we believe in working with thriving communities, and responsible procurement is a big part of what we do. And the work you're going to hear about today is very much related to our belief that responsible and sustainable forestry hinges very closely on research and sound data to do our work. I'll also remind you that SFI's board is three-chambered with representatives from both economic, environmental, and social groups. So you can see this is the makeup of our board currently, and this allows us sort of a broad spectrum across the entire sustainability spectrum of forestry and forest management and thriving communities. SFI's work is primarily based on three focal areas. Looking at this slide from right to left, a major focus of our work now is education and community engagement. For those of you who may not be aware, SFI recently partnered with Project Learning Tree, and Project Learning Tree in the U.S. is very much a part of our organization now, and we are not only working closely with PLT in the U.S. as they are under the SFI umbrella. We're also bringing them to Canada with Project Learning Tree Canada, and that initiative is underway. We also work heavily in the area of conservation leadership. A lot of this is through our conservation impact work, which you're going to hear a little bit about today. And this is really striving to understand the positive value of forest management and forest managed landscapes for both communities and industry and environment right across the board. And finally, probably what we're best known for is our supply chain assurances work. That's the SFI standard itself. And how we derive value for our program participants in helping the public and decision makers understand the value of sustainable forest management across the board. One of the really incredible things about the SFI standard is the number of acres across North America that are certified to the SFI standard. And what that means is, because of the scale across North America that we have, it gives us a great ability to think about environmental impact and what we can do positively for the environment right across North America, from all the way from Canada's boreal forest to the U.S. South, with a little over 3 million acres certified, or 123 million hectares. That's a lot of ground to cover, and really gives us scale to make a difference right across the continent. A big part of this work is what we call our conservation impact work. Now, SFI has been working for a number of years now. This initiative was kicked off about 5 years ago to really think about how we can demonstrate and how we can help show the positive attributes of forest management and what it does for the environment and for the forest. Now, this, I should say, is in addition to the work that our SFI program participants have already been doing. Companies right across North America, you can see the breakdown here of the amount of money invested into forest research since 1995. $1.6 billion invested in forest research. That's a lot of money. That's a lot of effort. So our members are very proud of that, and we are proud to support them with the conservation impact work, which is on top of that. So why conservation impact? We understand that our brand owners need to understand the impact of their sourcing. Program participants obviously need to justify the cost of certification. And then on top of that, conservation stakeholders really need to better understand the value of certification, what it brings to the landscape. And we believe that the improved understanding of all this will facilitate continual improvement within the SFI standard itself. So research that informs the standard going forward. Now, when we first got together with our Conservation Impact Sounding Board, the three main topics that were identified were water, climate change, and biodiversity. And it's within that field, in particular within the climate change focal area, that we're going to be talking about the project today. So why carbon? Why we focus on carbon specifically? The initial focus of the work within the conservation impact work was on climate change resiliency and carbon sequestration. Obviously, climate change, you only need to read the newspaper tomorrow. You realize that climate change continues to be a global issue that everyone is focused on. However, as much as there's been a lot of interest in markets and things like that, markets have really come down to a regional scale. There isn't so much a strong global market for carbon at this point, but nonetheless, mitigation efforts continue to be important. But we really need to develop a better understanding of how to develop best practices around carbon and what we can do to help manage carbon. Now, within that, SFI's conservation impact research has within the context of carbon, we know that past research has generally shown that well-managed forests tend to be carbon sinks. Lots of caveats around that, but in general. We also know that this concept that forest management, sustainably forest managed areas as carbon sinks is something that's poorly understood and not terribly appreciated by the public or decision makers. So that's something we want to work on. And forest management practices and how they affect carbon is something that will still require more study. So you see here a list of projects that we've been working on, carbon and climate resilience projects. And the third one down there is highlighted because that's the project we're going to be talking about today. This is the Saskatchewan Research Council Canadian Forest Carbon Assessment. This work is co-funded with the Forest Products Association of Canada. And at this point, I would like to hand off the presentation to Mark Johnson, who will give you a little bit of background on the project and how it came to be. So over to you, Mark.
All right. Thanks, Darren. I guess we'll just take a minute to get the other slides up, the other set of slides.
Mark, can you see it? It should be up.
No, all I've got is Darren's last slide.
Okay, wait 1 second. Okay, how now? How about now?
Yeah, there it is.
Okay, all yours.
You want to enlarge yeah, there we go. So I'm just going to give a very brief introduction. Again, I'm Mark Johnston with the Saskatchewan Research Council in Saskatoon, and discussions with SFI on this project began in 2014, so this idea goes back quite a ways. And it became apparent right at the very beginning of those discussions that the scale of the kind of analysis that SFI was looking for would require very significant computing infrastructure and large data sets. And the CFS is really the only organization in Canada that has that technology and the data, and also has about a dozen years experience in undertaking these very large landscape scale assessments. So we started talking to CFS about this in 2015, and the challenge there was just to try to understand how this project could fit in among all of the other carbon assessments and other related activities that CFS already has going on, and you'll hear about those in a few minutes. So in the fall of 2016, the Research Council and the Canadian Forest Service submitted a proposal to SFI under their Conservation Grants Program, which Darren just mentioned. And so the project was kicked off, and the work began in earnest, I guess about a year ago now. And as Darren mentioned, FPAC has kicked in some additional funding, and that allowed some additional area to be included in the analysis. And so where we stand right now, you'll see a map of this a little later, but what we've landed on then is the study area including parts of Vancouver Island, SFI certified land in Alberta, and SFI and non-SFI land in Saskatchewan, Manitoba, and New Brunswick. So with that introduction, I'll turn it over to Byron, who's going to go through the technical details of how this is going to be done. Or Werner.
Yeah, it'll be me, but that's fine.
Okay.
Byron has helped put this together. So good morning and good day, everybody. I'm Werner Kurtz. I'm a senior research scientist with the Canadian Forest Service in Victoria, and Byron is working on our team, but he is located in Edmonton. I am leading the team that puts together the National Forest Carbon Monitoring, Accounting and Reporting System for Canada, and have been doing this for many years. So what I will be talking about today is the work of the work with SFI and FPAC, and I'll just present a quick background and talk about the motivation for this project, put it in the national context, describe some of the methods we're using, and give you examples of preliminary results. I will speak briefly to the opportunities for collaboration with SFI and FPAC members, and then present some conclusions, allowing time for questions and answers at the end. We all understand that the impacts of climate change are already occurring today, and we all also understand that they will increase in the future. We have seen in 2007 a pretty much unprecedented year in many parts of the world, whether that was extreme hurricane seasons, mountain pine beetle and other insect outbreaks around the world, thawing of permafrost in Siberia, melting of ice caps, wildfires in Greenland, peatland systems, and in the upper right-hand corner, of course, the big story of 2017, the wildfires that occurred in many parts of North America, Europe, Australia, and other countries. To put things in perspective, the wildfire emissions in British Columbia in 2017, in a matter of a few weeks, released as much carbon dioxide to the atmosphere as 3 to 4 years of emissions from all other sectors in British Columbia combined. So needless to say, the questions around forests, forest management, but also risks to climate change impacts are top of mind for many people. And the recognition that climate change impacts are having an impact has led to the 2015 agreement under the United Nations Framework Convention that is commonly referred to as the Paris Agreement. It set a very ambitious temperature target, keeping the goal of the global average temperature increases to well below 2 degrees centigrade. What matters for us as land managers or people involved in land management is that 148 countries in their nationally determined contributions, these were the submissions made to the United Nations Framework Convention, identified that they will be using the land sector in achieving greenhouse gas emission reduction targets. The reason for that is that the IPCC scenarios that can take us towards the 2 degrees centigrade, as shown on the left-hand side, require that a peak in CO2 concentrations occurs before the middle of this century, and that CO2 emissions are reduced afterwards. The graph on the right shows you a series of scenarios. The one that has a 60% probability of keeping us below 2 degrees centigrade is the 2.6 watts per square meter warming scenario, so the light green one. And what you see there is that in order to achieve this outcome, we have to have net negative emissions in the latter part of the century. What that means is that the removals of carbon dioxide from the atmosphere due to human activities have to exceed the releases of carbon dioxide to the atmosphere. And of course, everybody is looking to the forest sector as a way of contributing to these greenhouse gas emission removals. To be clear, this problem cannot be solved without dramatic reductions in fossil fuel emissions around the world, but it's also important to understand that the land sector has to play an important role in removing carbon dioxide from the atmosphere, and how this can be achieved is, of course, of great interest. In Canada, we have seen a really big change in the approach in the last couple of years. Of course, we all are aware that a few years ago, FPAC made an announcement around the 30-30 goal, 30 by 30 goals, so 30% reduction by 2030 in greenhouse gas emissions in the FPAC sector. But more recently, the federal government has announced the Pan-Canadian Framework on Clean Growth and Climate Change, and in particular has set aside and created the Low Carbon Economy Fund. In British Columbia, we've seen an announcement in February 2017 about the Forest Carbon Initiative, a $150 million investment, to which another $140 million are expected to be contributed by the federal government. All of this is because there is increasing recognition of the importance of the forest sector and its potential contributions to climate change mitigation. But what this requires is an ability to improve our science in order to help us identify climate-effective mitigation options, but also to establish historic and forward-looking baselines of future greenhouse gas emissions and removals. The first thing is necessary because not all greenhouse gas mitigation activities are equal. Some, in fact, are proposed as climate mitigations, but are in fact adding carbon dioxide to the atmosphere. Others are clearly superior, and so the ability to distinguish the effective from the ineffective is very important. And the way this is done is by establishing a baseline. First of all, understanding the current emissions and removals, then projecting these into the future under business as usual scenarios, and lastly, identifying and applying mitigation actions. We have long argued that the only way to do this correctly is by using a systems perspective. That means we need to not only look at how much carbon is stored in forest ecosystems, but we also need to understand the contribution of forests to storing carbon and harvested wood products, and we need to understand the changes in emissions that result from substitution benefits achieved through the use of wood products and biomass for replacing fossil fuels. And all of this needs to be done relative to a business-as-usual base case without the mitigation scenarios. In Canada, we are fortunate in that work on carbon budget modeling started in 1989. The first version of the carbon budget model was developed, started in 1989, and since then we have advanced this development. And since for 13 years now, the National Forest Carbon Monitoring and Accounting and Reporting System is using the CBM CFS3 as the core model to represent greenhouse gas emissions and removals. The reason this is done at the national scale, of course, is that we have reporting obligations to the United Nations Framework Convention. We have obligations under the parliamentary requirements to report on the state of Canada's forests. We need to be able to not only report what happened in the past, but also make projections into the future, as this is essential for developing climate mitigation and adaptation strategies. So at the core of this system is the carbon budget model of the Canadian forest sector. We don't have time to go into great detail, but suffice to say that this model has been around for a decade, and the third version of the model has been around for more than a decade. It's widely publicized. We have numerous peer-reviewed publications describing the model, describing its application at the national scale, describing the uncertainty analyses. That was just published a couple of months ago. And science is continuing to try to improve the representation of the key carbon fluxes in the model, such as described in the paper that was just published a few weeks ago on additional constraints. This national model is applied for the managed forest, so the colored area in this map, and it's done in a spatially referenced approach. Spatially referenced means that we have about 600 management units across Canada for which we describe carbon stocks and fluxes, but we do so in a tabular fashion. So for each of these management units, we are using inventory information, growth and yield information, and other data, but everything is spatially referenced, and so we're not capable at the moment, or we were not able, and this is why we're doing this project, to have direct linkages between specific events and specific inventory records. So this has to the recognition in 2012 and maybe even earlier, as outlined in the Blueprint for Carbon Science in Canada, that there is a need to move towards spatially explicit modeling. There's really three reasons why we need to do this for science. We want to be able to accommodate the use of newly available remote sensing data that give us much better information on inventory characteristics and disturbances. This will allow us to better represent the impacts of disturbances, but also of management activities, particularly climate change mitigation activities. And also it will help us better link the impacts of climate change and other environmental changes such as carbon dioxide concentrations, as well as topographic and soil data when deriving estimates of forest carbon dynamics. For reporting, Canada has recently changed the reporting approach in that we separate anthropogenic lands affected by predominantly anthropogenic activities from lands affected by natural disturbances, but that also requires that we monitor post-disturbance recovery and any activities that may occur on these lands. And also for reporting, it's important to be able to demonstrate to the world that where we invest into climate change mitigation activities, such as under the Pan-Canadian Framework, that there in fact are climate effective outcomes resulting from such activities. And for mitigation, the third big topic, we want to be able to analyze mitigation options with consideration of spatial information such as road networks and communities, and the identification of climate effective mitigation actions that are regionally differentiated, because clearly, you know, there is no one-size-fits-all solution to climate change mitigation implementation. So that's sort of the background. You may be aware that the Canadian Forest Service, the team by Mike Wolder and Joanne White, in collaboration with folks at UBC, has produced a time series from 1985 to 2010. In fact, it was recently extended to 2015. That shows in annual time steps at 30-meter resolution the occurrence of clear cuts and other land clearing activities, as well as wildfires for all of Canada. And we are in the process of developing the tools and the infrastructure that allows us to use these kinds of annual data and very high spatial resolution to help inform the greenhouse gas balance of a forested landscape. Here is another version of the sort of summary information. You can see in black and in red the wild areas affected by wildfires and harvesting. Of course, harvesting exclusively occurring in the managed forest, wildfires occurring predominantly in the unmanaged areas, but some, of course, also occurring in the managed forests. So being able to have these kinds of data available requires that we also improve our computing infrastructure and computing technology to allow us to implement these, to process these very, very large data sets. So I have been collaborating for some years now with my colleagues in Australia that are also world leaders in developing national carbon accounting systems. And we have jointly developed a platform that is called the Full Lands Integration Tool, to which we have attached the science modules of the CBM CFS3. We have recoded all of the CBM CFS3 functionality, or almost all, allowing us to represent tree growth, litter fall, the dynamics of dead organic matter and soil carbon pools, the impacts of disturbances and forest management, etc. And when we applied this to a national test data set using the spatially referenced data, we obtained identical results demonstrating successfully that what we have done did not impact the science of the estimates, but it allows us now to run much, much larger spatially explicit data sets. The approach is also highly modular, allowing us to develop new scientific modules. For example, on mosses, we're just working on a moss module, which in eastern Canada is very important, particularly in black spruce ecosystems. We're working on a peatlands module, and we are in the process of starting to search funding to also deal with a permafrost module. So this work that we're doing with SRC, for which I will give a little bit more information in a moment, is just one of several projects, as Darren said at the beginning, that is using the GCBM for analyses in Canada. Obviously, one of the overall goals is to move our entire National Forest Carbon Monitoring, Accounting, and Reporting system to a fully spatially explicit system. We want to also expand it into the unmanaged forest because those areas are important for climate change feedback. We're applying this for British Columbia, and in fact we have all of BC running at 1 hectare resolution right now, with some areas with data gaps. For the Forest Carbon Management Project of the Pacific Institute for Climate Solutions, we're working with Parks Canada on a 30-meter resolution analysis of carbon densities in their forests and national parks. We're doing analyses with the Northwest Territories government that is being led out of Northern Forestry Centre by Ron Hall and his colleagues. We're doing a peatland modeling project with a number of people from across the country, with leaders at Northern Forestry Centre and Great Lakes Forestry Centre. And we're in discussions with several provincial governments who also want to use the GCBM for some of their analyses. So fundamentally, for those who know how the CBM CFS3 works, it is GCBM is very similar. It uses very similar input data. We require forest inventory and growth and yield data. We have data on natural disturbances, as I outlined earlier, using a number of data sources, including these new national products. We need forest management activity data. Again, these can come from the national products or from the provinces or industry partners. Canada has a reasonably well-developed land use change and deforestation monitoring system that at the moment does not produce spatially explicit data because it is based on a sampling system. So that's another data need. And of course, then we need climate and soil and other modeling parameters that allow us to improve the representation of carbon dynamics. So to give you a sense of the spatial coverage, the SFI project is currently focused on SFI certified lands in 5 regions from coast to coast. And that would be Vancouver Island, Alberta, Saskatchewan, Manitoba, and New Brunswick. And we are, as you see here, in the process of running the model for some areas. In others, we're still in the process of acquiring data, or even before that, reaching out to data providers. I'll focus on one example for Saskatchewan. This is the Pasquia Porcupine FMA in Saskatchewan. We ran about 1.5 million hectares at 1 hectare resolution in annual time steps. And the map on the right shows you forest cover and the carbon density in 1 hectare resolution for the forested part. And I will start the animation in a moment. And also, before I forget, want to thank the data providers. The reason we're starting with this area is because we were able to obtain the FMA data for this area relatively early, and so that allowed us to get going with this project. The graph at the bottom will show you the area harvested, the area affected by wildfires per year, with a scale on the right-hand side, and the scale on the left shows you the carbon density in that landscape, and it's changed over time. I don't know if you can see my mouse, but you'll see up here in a moment, in 2003, a big fire will occur now. And so, what this already is very useful for is that we recognize from these kinds of data that this large area burned, but in fact, it was not necessarily affecting forest areas, so that has implications for emissions, etc. The next slide for the same area shows you the net biome productivity. So this is a measure of carbon balance for the landscape, with the blue being sinks. So this is reported in tons of carbon per hectare, and it is reported from the perspective of the ecosystem, not the atmosphere. So the convention in this case is a positive value is a sink, a negative value is a decrease in carbon stocks in the ecosystem. And you can see the history of past disturbances reflected in the areas that have been sources. And as when I start the animation, you will see that some of them over time turn into sinks as the forests regrow. You will also see in the bottom, on the left-hand side, net biome productivity. So that's the net ecosystem carbon exchange, including the impacts of disturbances. Net ecosystem productivity, that's prior to the impact of disturbances. And the third curve is the transfer, the annual transfer of carbon to harvested wood products. this is all normalized to a hectare of forest area. And so I'll start the animation now. And so what you can see is that these forests are a sink. There is a transfer out of the forest of about 0.2 tons of carbon per hectare in annual harvest. Then the harvest rates are increasing. Fires also have increased, and that means that net biome productivity, so the forest became a source for a few years, as you can see from the changes in colors in the maps. And then these forests are starting to recover as the simulation progresses. Let me just see if I can run that one more time. So this gives you basically on a hectare by hectare basis for the forests that we're conducting this analysis for, the spatial distribution of carbon stocks, spatial distribution of carbon fluxes. And I should add that the losses that are reported here are, of course, due to, some of the losses are due to fire, some of the losses are due to transfer out of the ecosystem. What we are not doing in this analysis is keeping track of the harvested carbon in the harvested wood products model, which we have, of course, for other work. We're also not looking at the substitution benefits that are achieved. So this is strictly an analysis of ecosystem carbon stock changes associated with these activities and disturbances.
Werner?
Yes.
If I can interrupt you just for a second, the animations are working, but they're very, very slow. So I think it takes folks a little bit to catch up with you.
Okay. So
now you've moved on to scientific challenges, but maybe I just go back to that last slide and run it just one more time and let it run a second, because it's lagging significantly, but it is there, which is the good news.
Okay, so I'll run it one more time. You can see the map colors changing subtly. Part of the reason we do this for a relatively small area is because the larger the area we would want to display, the poorer the resolution. You can see very clearly the increase in harvest rates after about 2000. So that bottom line that shows the annual transfer of tons of carbon to the harvested wood product sector is increasing. And that, by the way, is shown in absolute values, not in per hectare values. The fluxes are on a per hectare value. You see the source around 2000, peaking around 2005, when both harvest and post-fire impacts affect the landscape. And then you see around 2000, 6, 7, the transition back to a sink. And it stays a sink until harvest rates are increasing again around 2015. As I said before, the impact on the atmosphere is different, because here we assume that anything taken out of the ecosystem is a loss to the atmosphere. Of course, that is not correct. We know that harvested wood products are also storing carbon and furthermore contribute to substitution benefits. So has the animation completed now, Darren?
Yes, it has.
Okay. Then I'll move on. So we have a few scientific challenges, as always. Data are always an issue, but one of the other ones is identifying and linking the yield curves to the inventory data. So this is an enormous amount of work, as you can appreciate, for the large area that these analyses are attempted for. One of the scientific issues that we're not working on in this project, but that is always a big issue, and we have been addressing it in the PICS project, is getting a better handle on the interactions of climate change and CO2 concentration increases on growth and mortality rates. If anybody's interested in that, we have a few papers that came out on that recently, but we're not yet in a position to do this very well for the large areas that we're working with. So at the moment, we're limited to using existing yield curves for these past analyses. And then another issue that is recognized is that the way in which we spin up the model to initiate dead organic matter and soil carbon stocks is very much designed for landscapes that are subject to historic natural disturbances, and where, like the boreal forest, where most of the harvesting that is occurring right now occurs in forests that were not previously harvested. However, there are regions in Canada, such as eastern Vancouver Island or some of the Atlantic provinces or southern Ontario and Quebec, where in fact some of the harvesting is second, third, or fourth rotation, and we need to make sure that the initialization of the dead organic matter carbon pools in those conditions reflects the longer-term management history in these stands. Again, this is something that we can take offline if anybody's interested. So, part of the reason we're giving this presentation is to inform you all about this collaborative project between CFS, SRC, SFI, and FPAC, but also to identify your role in the project. The success of this project depends in part on access to local forest inventory and yield data. Yes, it is possible to do this with remote sensing-based approaches, but we think that it's preferable to reduce possible sources of error that still exist with these remote sensing-based approaches, and more importantly, that we ensure that the results that we obtain are consistent with the forest management planning data that are used by provinces and industry. So one of your contributions, we hope, will be the sharing of data that will help inform this kind of project. We would also like your participation in the review of input data, assumptions, and results. But there's also something in it for you. Of course, the results that are generated using this approach will be made available to the data providers. And not only that, if and where there is interest to conduct these analyses using your own infrastructure, we can provide the tools to active project participants. These are fairly sophisticated tools, so this is not something that you can sort of pick up like an Excel spreadsheet or a simple web app, but most industry folk have sophisticated analysts in their team that run Woodstock, Stanley, Patchworks, or other tools, and so learning how to run this kind of tool is certainly well within their capabilities. It may not be within their available time. So expected outcomes from the project are first and foremost the improvement of the understanding of carbon fluxes, carbon stocks, and transfers of carbon into wood products that are required to meet society's needs for timber, fiber, and energy. Forests and the forest sector is a good news story in general, and we need to continue to lay the foundation to provide the data that allows us to communicate this good news story credibly and transparently to the public. We're also asked to produce a roadmap about how this kind of work could be taken to all of the SFI land base in Canada and the United States. And in the United States, this is a bit of a different challenge because of the very different inventory data approach that they have. There's also something in it for NRCan and the federal government, and of course that is that it will the outcomes of the product will ensure that the data and methods can inform Canada's NFC Mars 2.0 and create consistency between information that is used by SFI and FPAC, member companies, and the international reporting by Canada. And one of the other intended outcomes is to help identify the impacts of certification on carbon stocks and carbon fluxes. So in conclusion then, this is a project that is developing spatially explicit estimates of forest carbon stocks and fluxes for SFI certified lands in 5 provinces for the period 1990 to 2016 at a spatial resolution of 1 hectare. This is part of a national collaborative efforts to improve the understanding and analytical capabilities to estimate and report forest carbon dynamics. And of course, these data and tools lay the foundation for, in the future, using these to design and assess climate change mitigation activities. I want to be clear that the objective of this project is simply to improve the data and tools for the historic period, 1990 to 2016. But in our modeling framework, it is also then possible to make projections of these data that is beyond the scope of this project, but it is something that we're already working on. For example, in the Pix Forest Carbon Management Project, we have analyses to 2070 for BC and also for Ontario at 1 hectare resolution. So with that, I should acknowledge the contributions of SFI and FPAC for this project. There's also significant in-kind support from the CFS And of course, this would not be possible without data providers in industry and provincial governments. The people that are your primary points of contact are myself and Mark at CFS and SRC, Darren at SFI, and Kate Lindsay, who I believe is also on the call. I saw her name earlier, from FPAC. And with that, back to you, Darren. I'll stop sharing my screen here, and you guys can take it over, and I'll be happy to answer questions.
Thank you very much, Werner. As Werner said, I don't know if you caught that last slide he had up, but you can certainly contact myself or Kate Lindsay at FPAC if you have any questions on this project, or go directly to the source and speak with Werner or Mark. At this point in time, I need to do a shameless plug. If you really want to know more about the work that SFI is doing, not only in conservation impact, but across the value chain for forestry, I would invite you to save the date and attend our conference in Colorado. It's a fascinating conference. You will learn a frightening amount of information. I also need to remind you, as I did at the top of the recording, we are recording this webinar, and it will be available for viewing at a later date. Rocco Saracena, our Manager of Conservation Partnerships, is at the helm doing the recording and getting this ready. And with that, I would like to open the floor up to questions. Now, if you would like, you can type questions into the participant feedback box on your webinar, or you can raise your hand, and we will keep an eye on that, or you can just interject verbally, and hopefully we can sort it all out. So with that, we would love to have some questions, comments, or discussion about the project that you've just seen. Anyone at all? Perhaps while we are waiting for folks to pony up, I will mention that we also have our conservation impact work has what we call, and you heard me reference it earlier, our conservation impact sounding board. This is an opportunity, a wide open opportunity for anyone who would like to learn more about the conservation impact work that SFI is doing and contribute to that discussion. We have our next meeting is being held in Washington, D.C., March 6th and 7th, or 7th and 8th, 6th, 7th, and 8th, somewhere around there of March in Washington, D.C. You can contact myself or Rocco if you have any other questions about that. Okay, so we have a couple of raised hands. Rocco, can you moderate that? Because I don't know if I can control it.
Yeah, certainly. So I saw Greg Adams and Kate Lindsay's hand go up at the exact same time, so I guess we can do it alphabetically. And Greg, you can go first. Why don't you, I'm not sure if you would prefer to type your question in or if you would just like to speak up. You're not muted, so you should be able to talk through the phone line.
Yeah, I just wanted to know how product pools are being integrated into the ongoing work.
Yeah, so this is always a question of scope creep. So what we're doing right now is we have a harvested wood products model that is being used for national and international reporting at the scale of provinces and above. And it informs Canada's national greenhouse gas inventory. We're also using the harvested wood products model plus a tool to help us estimate substitution benefits in the mitigation analyses. So again, this project that we're doing right now and that we described here is basically ending at the moment the log leaves the forest. We are reporting here only on ecosystem carbon fluxes and stock changes, but we, of course, will always make sure that people understand that there is a whole second part to this story, which is the carbon stock changes in harvested wood products, which have been increasing in recent years across Canada and abroad, where harvested wood products are also tracked if they were harvested from Canadian ecosystems. And of course, the use of wood products is also contributing substitution benefits because long-lived wood products substitute for steel, concrete, and plastics, but also because biomass that is generated as part of the process in various stages, forest management process, in various stages from harvest residues to processing residues to construction residues to post-consumer residues. All of this biomass can also contribute to bioenergy production. So this project is strictly about ecosystem carbon balance, but we have discussed from the beginning that the bigger issue also need to be addressed, and our team, of course, is working on that as part of other projects, and SFI and FPAC will benefit from that and have in the past benefited from that already as these tools are being developed using other sources of funding.
Thank you.
It's Kate. Is that all right? I'll just go ahead, Rocco.
Yeah, please do.
Yeah, and actually my question was very similar. I was going to ask about the potential of including the harvested wood products number in the future, but you've answered that. Thanks, Werner. The other question was generally on the same example that you gave in Saskatchewan, which I think was really excellent to see the visual illustration that is focused on above ground carbon, ecosystem carbon. Is there an opportunity in the future to look at below or soil carbon, peatland, wetland, as information is collected specific to those stores moving forward?
Yes, so I should have made that clear in the presentation. The second slide that you saw, the second animation that showed net ecosystem productivity and net biome production. Net ecosystem productivity is the sum of carbon uptake through forest growth and losses of carbon due to heterotrophic respiration. So that slide already included all the dead organic matter and soil carbon pools in its analysis, and the flux, both fluxes that were reported there are the net balance of growth and transfers of litter due litter fall and dead trees, residues left behind after fires or harvesting, and the decomposition of all of that dead organic matter. Yeah, we can generate similar animations for the components and the fluxes. The model keeps track of biomass in multiple components above and below ground live, as well as various pools that represent the litter, the woody debris on the sites, as well as soil carbon stocks. As far as peatlands are concerned, these deep organic soils are a challenge for us, and that is why we are developing the peatland module that is being tested as we speak. This is not ready for implementation at the scale that we're talking about here, although we are, one of the pilot sites that we will be using will indeed be Saskatchewan. And so we can certainly report on that by the end of this project, although I am reluctant to make any commitments to include wetland and peatland fluxes in this analysis that is currently planned. As you can, I mean, doing this large tract of land at 1 hectare resolution is already pretty ambitious. One more comment on the harvested wood products. One of the challenges that we face right now, of course, is that the data that we have at the national scale are derived from national statistics, from FAO and other sources, Stats Canada, and they do not provide us with the detailed fate of the material that is harvested at any one location or management unit. And so one of the challenges that we have in Canada is that we don't have good data on interprovincial transfer of wood, nor do we have good data on sort of the fate of wood harvested from any management unit. It's an enormous effort to try to compile that, and it's a bit of a fool's game because you really don't know ultimately where all this wood ended up. But I think for the purposes of making and communicating a story, we can certainly demonstrate using some of the national statistics the average fate of wood harvested in Canada and describe the contribution that these products make to storing carbon in harvested wood products, in some cases in landfills, and the substitution benefits that are achieved through the wood use.
Great, thank you, Werner.
Werner, we have a typed-in question from Daniel who says, understanding the needs and limitations of the regional or continental model, how does the model perform at a local scale, and what are the needs at the local scale for the model to perform better?
Yeah, so that's an excellent question. When I assume we're talking about the ecosystem model and not the harvested wood products model, but maybe Daniel can confirm that. I will start by answering the ecosystem model aspect. So one of the things that the national model, thanks Daniel, one of the things that the national model does is it has to make assumptions about where certain disturbance impacts occur. So we know for a management unit that X hectares will have been harvested and Y hectares will have been burned, and then the model in its old form needs to use rules that say, okay, well, harvesting usually occurs in mature forests and with this leading species, et cetera, and the model then selects from the inventory that is aspatial stands that are deemed eligible for harvest. They have to meet certain rules. They have to not be in a reserve or non-timber harvest land base in the case of British Columbia, et cetera. Same with fires. The rules are usually just a random selection of stands. With the spatially explicit approaches now, we can actually do this very differently and actually align the harvest or disturbance impacts with the forest characteristics and fuel loads of the sites that these events have been recorded in. Moreover, we are doing experimentation right now. Again, this is beyond this project, but what we're doing in the PICS project is we had a postdoc who unfortunately now got a, well, fortunately for him, unfortunately for us, got a permanent position and left the project, but we have done some work in British Columbia using yield curves that are derived from statistical models that take into consideration things like slope aspect, the water receiving area of a stand, et cetera. So as we move forward, there will be lots of opportunities now to refine the information about the stand dynamics as well as the dead organic matter dynamics with information that is specific to the site. So we're opening up a whole new area of research and improvements, but having said that, this is all very ambitious, it's costly, but because these tools are open source, we will provide, in the future, these tools to interested parties. So if a forest management company or a land manager wants to apply that to their piece of real estate, they can certainly do so with their own data, and they can then also look at the opportunities for improvement, whether that's better yield curves or refinement of the forest management impacts. Obviously, there are many different types of harvesting that can be applied. They can be applied at different seasons with differential impacts on dead organic matter pools. It could be with and without slash burning or residue removal. So all these kinds of things will now be possible in a much more transparent way than it was possible before. So it's a pretty exciting time. The opportunities are great. The workload is increasing exponentially, but the demand for this kind of information is also increasing exponentially. And I firmly believe that if we can demonstrate credibly the benefits of forest management and carbon management, we will be able to sustain public support for carbon management based on forest management activities and wood product uses.
Perfect. All right. Thank you.
Thank you, Werner. Any other questions? Last call for questions.
Well, from my perspective, I have one more comment to make, and that is we have reached out to a number of you across the country to get access to data. We have a wide range of responses from having received data to discussing data sharing agreement to no response at all. If you are a recipient of a request for data or want to provide data for this kind of activity, we would very much welcome if you could reach out to us, either Byron or Darren or Mark or myself, and let us know about this. If you have any concerns about this, also please please communicate these either to Kate and Darren or to Mark and myself, so that we can help you address those concerns should you have any.
Excellent point, Werner. Okay, so seeing no more questions at this point, I want to thank everyone for taking time out of their busy schedule to attend this webinar. I really appreciate that we don't all have a lot of time to spare these days, so it's good to see such good participation in this webinar. I will remind you again, if anyone is interested in the SFI's Conservation Impact Sounding Board Workshop, that is all day March 7th and half day until noon March 8th in Washington, D.C. Again, my email is on the screen. If you'd like to contact me, I can give you more details about that. Otherwise, I thank